Okay, this is section 1.8, part 2. In this second part, we will be solving absolute value inequalities. I have written down here, earlier in our notes, we developed some guidelines for the inequalities, but I don't want to scroll up because my computer sometimes doesn't cooperate. But let me just remind you, we had these little guidelines here. Summary of some inequalities. So the absolute value of x minus the absolute value of x is less than a is equivalent to this compound inequality. The absolute value of x is bigger than a is equivalent to this inequalities right here. So I just kind of wrote that down here because we're gonna need it. Again, I didn't want to scroll down too much around because my computer doesn't like that too much, but that's okay. Just bear with me. We have 4 inequalities to solve. There are 4 inequalities to solve. I'll show them to you here in a second, and so that you get a chance to try them on your own. Let my computer just, there we go, it's happening. So absolute value inequalities, we're going to be needing this fact right here, that the absolute value of x is less than a is equivalent to this. The absolute value of x is bigger than a is equivalent to this inequalities. We're going to be needing these facts. And also keep in mind that the absolute value is always positive. So keep that in mind. The absolute value is always positive. So there's some tricky problems here. So these are 2 of the inequalities that you gotta solve. So you should be writing them down. So write this, the top one wants number 7 down, number 8 down. You wanna solve them. And there's 2 more, 9 and 10. I want you to try to solve this inequality and this inequality right here. So at this point, just copy these 4 inequalities down, copy them down, try to solve them on your own, and then let's compare answers. Alright, so let me begin with this top one. Hopefully you've gotten a chance to try them all, and you are confident in the answers that you got, and right now we're just going to compare. So let me go through the process here. The first thing I want to do, so right now I'm looking at the inequality that was given to me. What I want to do right now, the first thing I kind of want to do is isolate the inequality. Isolate inequality. So leave it all by itself. And on the left-hand side is where I have my inequality. It's just that there's this negative 15 kind of in the way. So to get rid of the negative 15, I'm just going to add 15 to both sides. Okay, so let me kind of then do that. Sorry, here. I kind of just want to organize my steps a little bit. This should go down just a little bit here. I apologize, I really don't know. I've tried many settings on the video and on the audio, and I think this is the best so far in terms of quality of the video, but then my computer always starts messing up right now, so I need to maybe figure something else out. It's a work in progress. Okay, so isolate the inequality. What that means is just leave it all by itself. So let me do that. 2x plus 7 is less than, I add 15 to both sides, so positive 15 minus 2, that's 13. And now I'm looking at my guidelines up here. Right now what I have is the absolute value of x, or the absolute value of something is less than a. So this should split up into this type of compound inequality up here. So I'm going to use this little guideline to help me get rid of the absolute value. So I'm looking at this little guideline up here. Right now my a is kind of like my 13, and right now I'm thinking of x as being this whole expression, 2x plus 7. So then what I have is this 2x plus 7. Come on. Sorry. Wanna just write, come on, just change to pen. I apologize about this. Okay, so we said 2x plus 7 is less than 13 and bigger than negative 13. And now I gotta solve for x there. So I'm gonna begin by adding a 7. Negative 13 plus 7, what is that? That's negative 6 less than 2x less than 20. And then remember that if you multiply or divide by something negative, the inequality sign changes. But right now I'm going to divide everything by 2. Okay, so then I end up with this. Negative 3. Negative 3 is less than x is less than 10. And now I just want to express this using interval notation. And so what is the interval notation for this? Let's see. So hang on here, hang on, give me 1 second. So we added 15 to both sides, that's good. So then we have that this is less than 13 and bigger than negative 13. I made a big mistake here. Where is my mistake? I hope that you realize it here. I added 7 to everything. I added 7 to all sides. I need to subtract a 7. I need to be subtracting a 7 here. Something doesn't look right to me here. Sorry, let's erase this. So mistake here, a mistake happened here. I need to subtract a 7. You see right here, I should have been subtracting a 7. I just want to erase all of this, if my computer allows me to do so. There we go. Okay, so back to this, I'm sorry. Minus 7, that's what I should have been doing, minus 7. Okay, so this is negative 20 less than 2x less than 13 minus 7. 13 minus 7 is 6. Yes. And then let's divide by 2. So that says negative 10 is less than x is less than 3. Now this is good. So then my answer, my solution is the interval negative 10 to 3. That's it for that one. Sorry, sometimes you make mistakes. That's okay. Next one. So let me think about this one. Alright, so I gotta solve that. Let me look at the little guidelines that we put up here. So we said that if we have the absolute value of something is bigger than, then we're going to end up with 2 inequalities. X is less than negative a, or x is bigger than a. So I'm going to use that right now and think about it like this. Also, right now this is convenient. The absolute value part is already isolated. If it wasn't isolated, that's the first thing we would want to do. We would just want to first isolate the absolute value part. But that's already taken care of for us, so we're good to go now. So this splits up into 2 inequalities. One of them is going to say, well, let me think about the easier one. The easier one is just literally erase the absolute value sign. So 4x minus 6 is bigger than 10. There's supposed to be some or right here. And the other one is going to be 4x minus 6 is less than negative 10. I mean, literally, I'm just looking at what we set up here. The absolute value of x is bigger than a. Well, you have, this is the simple one. You just erase the absolute value part. And the other one, you flip the inequality and make the other part negative. Okay, so that's where I'm at right now. Now I gotta solve both of these inequalities. So let me begin solving them. So I have that 4x is less than -4 here, because all I did was add 6. I add 6 to both sides. I'm going to add 6 over here as well. So I have that 4x is bigger than 16. Now I'm going to divide by 4. Just remember that if you have a problem where you divide or multiply by something negative, the inequality sign flips. Okay, so I'm going to divide by 4 on both sides. So that's going to say x is less than -1. Over here I'm going to divide by 4 on both sides. So that says that x is bigger than 4. And that is my answer. Now we want to express this using interval notation. So your answer kind of looks like this. So you have -1 with an open circle. You have 4 over here with an open circle. And the things that are less than -1, well, that's these things right here. And the things that are bigger than 4, well, it's all of this stuff over here. So then in interval notation, that looks like this. -infinity to -1 union 4 to +infinity. Yeah? And that's my answer. Okay, so hopefully you agree with that. Next example. Notice that I did not give myself too much room here to work with. So I gotta solve this absolute value inequality right here. And you're thinking, okay, well, let's just kind of do what we've been doing so far. Let's split this inequality into 2 inequalities without absolute value. But these are kind of tricky here. Both of these things right here are a little tricky. So let me just kind of put a little thing here. These are tricky. Here you gotta kind of pause for a second and think about what's going on. Anytime that you have absolute value and then on the other side you have something negative, and it doesn't matter what the symbol here is. It could be an inequality, it could be an equal sign. You should be careful. So think about this. The absolute value part is always positive. The absolute value is always positive. This is always positive, no matter what value of x you choose. So it doesn't matter the choice of x. The left-hand side will always be positive. And so then it will always be bigger than -2. So then what are the solutions to this? Turns out that all real numbers are solutions, because it doesn't matter what the choice of x is. I can pick any x, and then this absolute value part over here on the left hand side is going to make it positive, and that's always going to be bigger than -2. So the solution here is all real numbers. Well, let's just use interval notation for that. So -infinity to +infinity. This equation is satisfied by everything. Another way to think about it is that right now what you're asking is you're dealing with an absolute value graph, which looks like a V. And its little pointy part, it's called the cusp, hits the x-axis somewhere. And you're asking, when is that graph above the graph of a horizontal line that hits the y-axis at -2? Well, all the time. All the time. Because this is always above the x-axis, this is always below the x-axis. So here, the solution to this inequality right here is all real numbers. Because this is always going to be positive, so it's always going to be bigger than -2. Okay, last one. The last inequality that we do here. Again, this one's kind of tricky. Remember, the absolute value, no matter what choice of x I have or I make, the left-hand side will always be positive. The left-hand side will always be positive. So then, can it be less than -5? And the answer here is no. So the answer here is no solution. So the antiset. Yeah. So be careful with these types of inequalities. Anytime that you have absolute value and then you have something negative on the other side, pause for a second. Don't just go with the flow. Think for a second about what's going on, because keep in mind that the absolute value is always positive. The absolute value is always positive, And so then it's always bigger than something negative, and it cannot be smaller than something negative. Okay, so that's it for absolute value inequalities. And hopefully we agree on the answers if you worked out the answers ahead of time. Thank you, and I'll see you in the next video.